Test the convergence of the series where the nth term of the series is root n square plus 1 minus n. Now, if we see, this is not in a standard form. Okay. So, first we will convert this into a standard form. So, let us denote this as un. Un equals to root n square plus 1 minus n. So, to convert this into standard form, we will multiply and divide this by its conjugate. Okay. So, this is the conjugate. Okay. So, in numerator, this is nothing but a minus b, a plus b. So, simply we can say a square minus b square, where a is root n square plus 1 minus n square. Okay. Upon root n square plus 1 plus n. So, root n square gets cancelled. Simply remains n square plus 1 and minus n square. It means only 1 remains in numerator. And in denominator, root n square plus 1 plus n. Now, this is the standard form. Okay. But we have seen for comparison test, we need two series. Okay. So, just we have seen, we have denoted the given series as un. Now, we will find vn so that we can use this test. Okay. So, we can find the limit of their ratio. Okay. So, how to do that? So, we will do that in rough. Okay. So, this is the term, last term. So, if we observe, we can take n common from this and from this also. So, in denominator, we can take common n. How come? See, 1 upon root n square, if we take out, then here it remains 1 plus 1 upon n square, and this n as it is. Okay. So, this is plus 1 upon, if this n square we take outside the root, then we will get n. In root it remains 1 plus 1 upon n square plus n. If we put n as infinity, then we will get approximately n plus n, that is 1 upon 2n. So, we have to take vn similar to this. Okay. So, we will take, let vn is 1 by n. Okay. Now, we will apply the limit. Limit un by vn as n tends to infinity equals to limit n tends to infinity. Our un is 1 upon root n square plus 1 plus n upon 1 by n. It means multiply by n by 1. Okay. So, limit n tends to infinity n upon, if we take n common here, then we have already solved this here in rough. So, we can directly say n in root 1 plus 1 by n square plus n. Okay. So, limit n tends to infinity n, and here it is n. So, root 1 plus 1 by n square plus 1. Now, we will cancel this n. So, put n equals to infinity. What will happen? 1 upon 1 plus 0 under root plus this 1. 1 by infinity is 0. So, 1 plus 0. This is nothing but 1 upon 1 plus 1, that is half. So, by comparison test, this is a non-zero finite number. Okay. Now, as this is a non-zero finite number, we can apply here our comparison test. Okay. Now what does comparison test say? Both the series are convergent or divergent together. It means if one of them is convergent, then other will be automatically convergent. And if one of them is divergent, then another one, second one is also divergent. Now we can easily say that this series Vn, which is 1 by n, is divergent, and hence means as this limit is less than a non-zero finite number and Vn is divergent, we can say by comparison test our given un is also divergent. Understood?